Imagine that compared to the vastness of the cosmos, Earth is nothing more than a grain of sand drifting in an immense cosmic ocean. The universe is estimated to be millions of times larger than anything we can truly comprehend. According to scientists, the diameter of the observable universe stretches to about 93 billion light-years. To put that into perspective, a single light-year equals roughly 9.46 trillion kilometers. And even if you were to place every planet in the solar system inside one giant sphere, the space between them would still be enormous, revealing just how empty and silent the cosmos really is. What makes the universe even more mysterious? It's the existence of millions of galaxies, each containing billions of stars. The Milky Way, the home of our solar system, is only one among hundreds of billions of galaxies spread across the cosmos. And each star may host its own collection of planets, opening the door to endless possibilities for life and exploration. So, are you ready to step into this journey? This adventure to uncover the true scale of the universe. Between Earth and the Moon lies a hollow ocean that most of humanity has never visualized accurately. Its gentle silver glow deceives our intuition, making us believe that the distance is small, close, even familiar. But science reveals a completely different truth. This region of space stretches 238,855 miles. The Moon, in our perception, may seem large. Yet, in reality, its diameter is only 27% of Earth's. What makes the Earth-Moon distance so difficult to grasp is not the Moon's size, but the empty space that surrounds it between these two celestial bodies. There is almost nothing, only a deep, silent vacuum extending for hundreds of thousands of kilometers. Scientists estimate that the Earth-Moon void alone is enough to magnify our understanding of cosmic scale. When Apollo 11 traveled from Earth to the Moon in 1969, the spacecraft took nearly 3 days to cross that distance, even while leaving Earth at a speed of more than 39,000 kilometers per hour. This shows that the Moon is not merely far away, it lies beyond the boundaries of what the human body can naturally comprehend. The Earth-Moon gap is a region where even the smallest mechanical error can lead to disaster. It stands as proof that life can exist only under extremely strict conditions. This emptiness also teaches us a profound philosophical lesson. We tend to underestimate distances because our senses were designed for a small world, where just a few kilometers feel far. But the universe does not operate under the rules of nearness. It follows the rules of infinity. The existence of such an enormous void also reflects another truth. Emptiness is actually the foundation of all structure. Matter is merely a collection of small islands drifting in a vast cosmic sea of nothingness. From a cosmic perspective, life is the exception, not the rule. Earth is a speck of dust covered in life, floating in an immense and indifferent void. When Apollo 8 captured the legendary Earthrise, Earth rising over the lunar horizon, humanity saw its home for the first time in a context no one had ever imagined. A small blue sphere suspended in a boundless black ocean. No borders, no nations, only one fragile home surrounded by nothingness. The Earth-Moon void reminds us that life exists not because of the planet's grandeur, but because of the delicate, fortunate position it occupies in space. It is this very void between Earth and the Moon that opens the door to a larger question. Why can a single star control the fate of an entire system spanning billions of kilometers? The Sun, the system's only star, is the absolute ruler of everything within its reach. It is the heart, the wellspring of energy, and the axis around which all motion unfolds. And beyond that, it stands as the ultimate proof of gravitational dominance, an invisible force so powerful that it determines the fate of all things bound to it. The Sun contains 99.86% of the entire mass of the solar system. In other words, all the planets combined, even Jupiter, with a mass 318 times that of Earth, are nothing more than tiny fragments within the domain of this single star. In terms of volume, the Sun is so enormous that it could hold 1.3 million Earths inside it. A number far beyond human intuition. Beyond anything our evolution has prepared our minds to grasp. Inside the Sun's core, every second, about 600 million tons of hydrogen are compressed and transformed into helium through nuclear fusion. With each heartbeat of this reaction, the Sun releases more energy than 200 billion red dwarf stars in the universe combined. If measured by their ability to sustain a stable habitable zone, like the one Earth occupies, this energy is what created the oceans, the atmosphere, the water cycle, the seasons, and every form of life we know. Yet light is only a fraction of its power. Earth's orbit is the result of a perfect balance between the Sun's gravitational pull and the velocity Earth acquired during its formation. If Earth's speed were to drop by just 2%, it would fall into the Sun. If it increased by 2%, Earth would fly out of the solar system and become a wandering planet. Within this delicate range lies the Goldilocks zone. the region where temperatures are not too hot, not too cold, allowing liquid water to exist. If Earth were as close to the Sun as Venus, its atmosphere could transform into a labyrinth of sulfuric acid, with surface temperatures reaching 465 degrees Celsius. If Earth were as far as Mars, surface water could freeze entirely, making complex life nearly impossible. But Earth's fortune is not only its position, it is also protected by Jupiter with its massive gravitational field. Jupiter pulls in or deflects the paths of large asteroids, dramatically reducing catastrophic impacts. Disasters like the Chicxulub event, responsible for the extinction of the dinosaurs 66 million years ago, might have happened far more frequently, preventing complex life from ever emerging. All of this reveals that the solar system is a finely tuned, extraordinarily rare structure. The Sun holds everything in orbit through gravity. Jupiter acts as a distant shield. Earth possesses a strong magnetic field, a dense atmosphere, and a nearly circular orbit. And the Moon stabilizes Earth's axial tilt, reducing extreme climate fluctuations. Nothing in this architecture is unnecessary. Life on Earth is not a random accident. It is the result of hundreds of thousands of conditions aligning simultaneously. Even slight deviations might have prevented life as we know it from ever appearing. And all of it originates from one ordinary star. 4.6 billion years old, classified as a G2 V-star, not rare, not huge, not exceptionally hot. Yet it is this very moderation that grants the stability necessary for billions of years of evolution. Larger, brighter stars live fast and burn out quickly, far too short for complex life to form, while smaller stars blast their planets with intense radiation and frequent flares, stripping atmospheres clean. When we look beyond the gravitational empire of the Sun, we enter a scale hundreds of millions of times larger, the Milky Way. Yet what is astonishing is not merely its enormous width, but the distribution of metals, star density, radiation, and galactic dynamics that make this galaxy a relatively ideal environment for complex life. The Milky Way is a barred spiral galaxy with at least 4 major arms: Perseus, Sagittarius, Scutum Centaurus, and the outer arm, along with several smaller branches. Within each arm, massive molecular clouds continuously give birth to new stars. But this process comes with danger. Star-forming regions often contain intense radiation, stellar winds that blow away dust and gas, and frequent supernova explosions. For that reason, complex life if it appears at all, can only exist within a narrow band known as the galactic habitable zone. Modern scientific models suggest that the gigahertz lies about 23,000 to 30,000 light years from the galactic center. And our solar system lies precisely in that zone. Not too close to the center, not too far toward the edge. This is an extraordinary coincidence, because if the Sun were only a few thousand light years nearer to the center, Earth would face a stellar density tens of times higher than it does now. The solar system resides in a small branch called the Orion Spur, perhaps one of the most stable regions within tens of thousands of light years. The stellar density in our area is only about 0.004 stars per cubic light year, an extremely low number. This matters because low density reduces the risk of passing stars disrupting Earth's orbit. Beyond that, the Milky Way possesses a higher metal content than many galaxies of similar type. This is crucial because heavy elements, carbon, iron, oxygen, silicon, form the foundation of rocky planets, water, and complex molecules. Even more astonishing is that the Milky Way is currently colliding with and absorbing other galaxies. Yet we happen to live in a remarkably stable era. The Gaia Enceladus galaxy and the Sagittarius dwarf galaxy were once pulled into the Milky Way, disrupting major orbits. But the solar system formed after these chaotic events, meaning Earth emerged in a galaxy that had already cooled from its storms. Had Earth formed earlier, its orbit might have been torn apart by these colossal galactic collisions. In reality, the largest, brightest, and most massive galaxies are often the ones that are biologically dead. And it is here that we begin to understand something profound. Life does not exist in dominance, it exists in balance. Consider IC1 101, one of the largest galaxies ever discovered. Its diameter exceeds 400,000 light years, roughly 4 times the size of the Milky Way. And it contains trillions of stars, a number far beyond imagination. Yet when astronomers analyze the spectra and stellar distribution within IC 1101, they uncover a stark truth. Most of its stars are old, yellow or red, having burned through nearly all their fuel and now slowly fading. M87, the giant elliptical galaxy in the Virgo cluster, is even more extreme. At its center lies a supermassive black hole, 6.5 billion times the mass of the Sun. The first black hole humanity ever captured an image of. Another giant galaxy, a 2261 BCG, exhibits signs of extreme age to an almost eerie degree. Astronomers discovered that it has nearly no active star-forming regions. Its core is unusually wide, containing billions of stars but lacking a clear central black hole. An unexpected anomaly for a galaxy of such size. This suggests that A2261 BCG has undergone numerous violent galactic mergers, so intense that its central structure became completely disrupted. But after these collisions stripped away its cold gas, the essential ingredient for new stars, the galaxy was left unable to create fresh stellar generations. The common theme among supergiant galaxies is their history of repeated mergers. Each collision unleashes massive kinetic energy, producing shock waves that heat interstellar gas to millions of degrees Kelvin. At such temperatures, the gas cannot cool quickly enough to collapse into new stars. The result is that these massive galaxies become fortresses of hot gas, no longer capable of giving birth to stable star systems. Another issue is orbital chaos. In large elliptical galaxies, stars do not follow orderly paths as they do in spiral galaxies. Modern astrophysical simulations show that even a slight change in orbital structure is enough to fling a planet out of its system or send it spiraling into its star. For life, long-term stability is foundational, but in supergiant galaxies, stability is a luxury that does not exist. Furthermore, these massive galaxies once had extremely high supernova rates. This means gamma radiation, X-rays, and shock waves were once overwhelmingly intense. Such radiation destroys organic molecules, strips atmospheres from young planets, and eliminates any possibility for biological evolution to accumulate over time. Complex life, which requires long epochs of quiet, steady development, simply cannot endure a billion-year cosmic storm. Let us begin with the local group, the nearest galactic community to which the Milky Way belongs, consisting of about 50-60 galaxies, most of them faint dwarf galaxies visible only through telescopes. Within the local group, the Milky Way and Andromeda are engaged in a slow but inevitable gravitational dance. Dwarf galaxies such as the Large Magellanic Cloud and Small Magellanic Cloud orbit the Milky Way like distant satellites, playing crucial roles in supplying gas and dark matter to our galaxy through gravitational streams. Leaving the local group, we rise to an even larger structure, the Virgo supercluster. A vast supercluster of galaxies containing thousands of galaxies spread across tens of millions of light years. The local group sits on the outskirts of this structure, much like a small district on the border of an enormous city. At the center of the Virgo supercluster lies the Virgo cluster, a dense concentration of more than 2,000 galaxies, including giants like M87. With its supermassive black hole weighing 6.5 billion times the mass of the Sun. Here, galaxy density is so high that gravitational interactions happen frequently. twisting and mixing galactic structures over billions of years. The Virgo supercluster is not a static structure. Instead, it is a region in which galaxies are being dragged along by immense flows, gravitational rivers that observers on Earth cannot feel, yet that govern the movement of our entire galaxy. What makes Virgo significant in the cosmic map is not its size, but the fact that it is part of an even larger structure, the Laniakea supercluster. In 2014, scientists discovered that the local group, the Virgo supercluster, and many neighboring superclusters are all moving together along a shared gravitational stream, continuously pulled toward a special region of space. From this revelation, the concept of Laniakea was born. A superstructure roughly 520 million light-years wide, containing about 100,000 galaxies. The name Laniakea, derived from Hawaiian, means immense heaven. A remarkably fitting description for such a vast cosmic domain. At the heart of this motion lies the Great Attractor, a dense region of dark matter located in a direction that is difficult to observe because it is obscured by the Milky Way, generating a gravitational pull so strong that thousands of galaxies are drifting toward it. The Great Attractor lies within what is known as the Zone of Avoidance, a region shrouded by the Milky Way's dust and gas, making it impossible for telescopes to observe directly. When we look at the local group Virgo and Laniakea, we realize that humanity's cosmic address has no fixed point. It is not a stationary coordinate that can be pinned onto a map. Every layer is moving, drifting, twisting, and interacting through endless gravitational currents. And Laniakea itself is just a branch of even larger structures. Colossal galactic walls stretching billions of light years, interconnected by dark matter and enormous cosmic voids. Beyond Laniakea lie other superwalls, vast voids billions of light years across, and a grand interconnected network that binds everything together. The cosmic web. Once we step beyond the Milky Way, past the local group, and even beyond the 520 million light-year wide Laniakea supercluster, humanity might believe it has reached the border of the universe. But in truth, everything we see, galaxies, galaxy clusters, and even superclusters, are merely bright points scattered across a structure far larger, more intricate, and utterly beyond human intuition. That structure is known as the cosmic web, a vast network where matter is arranged into filaments, nodes, walls, and voids, stretching across tens of billions of light years, like the colossal skeletal framework upon which the universe itself is built. What makes the cosmic web extraordinary is not only its size, but the way it shatters all familiar concepts of structure. On Earth, we understand a world made of matter, mountains, oceans, cities, planets. Planets orbit stars, Stars reside in galaxies. Yet over 90% of the observable universe is empty space. If the Milky Way were shrunk down to the size of an atom, then the cosmic web would be as large as an enormous molecule, its branches stretching for billions of light years. The cosmic web is composed primarily of dark matter, the invisible substance that makes up about 27% of the universe's total matter-energy content. Yet does not reflect light, absorb light, or reveal itself except through gravity. Dark matter forms the unseen scaffolding that drags baryonic gas along with it, creating the backbone from which galaxies arise. As dark matter clusters, it produces gravitational wells where gas can accumulate, cool, and eventually ignite into stars. Regions rich in dark matter become galaxy clusters. Regions lacking dark matter become voids. Immense, almost empty expanses containing nothing but a few lonely galaxies. Among the largest structures of the cosmic web, the voids are the most astonishing. The KBC void, nearly 2 billion light-years wide, envelops the entire local group and represents an unusually underdense region near our cosmic neighborhood. The Buotes void, sometimes called the Great Nothing, spans about 330 million light-years, where the number of galaxies is hundreds of times lower than average. The local void, right beside the Milky Way, stretches 150–200 million light-years, and its extreme low density is actively pushing our galaxy outward. The South Pole Wall, spanning over 1.4 billion light-years, wrapping around space near the southern celestial hemisphere. The Hercules Corona Borealis Great Wall, the largest structure ever discovered, stretching more than 10 billion light-years, occupying nearly half the age of the universe itself. After an astonishing journey through the layers of the universe, the truth about its real scale becomes undeniable. Our planet, Earth, is nothing more than a tiny blue dot, insignificant in size. A grain of dust floating in endless space. From the immense proportions of the Sun and the Milky Way to the galaxy superclusters stretching across billions of light years, every familiar sense of scale dissolves. And yet, it is precisely this contrast that shapes the extraordinary value of Earth. Though it is so small it nearly vanishes on the cosmic map, it remains the only place we know that harbors life. A rare, fragile blue oasis amid the cold void. In the vast canvas of the universe, smallness is not a limitation. It is a reminder of the boundless potential of human curiosity and intelligence. It is our ability to ask questions, to explore, and to reach beyond the known that has brought us this far. And so, we must cherish and protect this precious home, while continuing the journey to unlock the mysteries of the cosmos. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.